Hi guys. So I'm trying something a little bit different today. So I'm going to do a lab and you're going to take the data, but I'm just going to show it to you because some of you are at home avoiding the coronavirus. Okay. So we're doing a density lab. And so you have something that you're going to go through in Canvas and I'm going to give you the data for it. Okay. So I'm going to do it right here in front of you now. Okay. Okay. So first, I'm going to get some of these little plastic jewels, okay? And we're going to try measuring a handful of these. You look, they're pretty. Woo, they're there. Okay, they're cool. Okay, and we're going to measure their density, and they're weird and irregular. So how you measure the volume of something weird and irregular, I'm going to show you that too. So to get the density of these, we have to find the mass and the volume of them, okay? So mass, I'm trying to do this on my desk, which is a little crowded. Okay, so for mass, we're going to use this electronic balance. All right. Okay, let me see if I can get that where you guys can see it. Okay, there it is. Let's turn it on. And there it goes. Okay, so now I've got this little handful, and I'm just going to put them on there. Okay, so you see that there? If you can see that, let me see if I can get that closer. Okay, so write down in your canvas what that is. Okay, so now you've got that. Okay, so now we just need to get the volume of them because we've got the mass, we just measured it. Okay, one way that you can get the volume of an irregular thing is you put a known amount of water in your graduated cylinder, okay? And what I have put here is, let me turn it so you guys can see, 50 milliliters, 50 milliliters of water, okay? So if I put these things in it, the water's gonna go up, okay? So here we go, watch it go up. There it goes, see it's going up. And it'll go up by the volume of these things, okay? Here. And supposedly the person who discovered this was Archimedes, who was a famous Greek scientist and engineer. And there's some bubbles in there, so I'm gonna stir that around a little. Get the bubbles off. And he figured it out when he was in the bathtub, supposedly. And so supposedly what he did is he sat down in the bathtub, he saw the water go up, he realized what was happening, and supposedly he jumped out of the bathtub, ran naked down the street, screaming, Eureka, Eureka, which means I have found it. Okay? So, and I know this is not perfect for you guys to be able to read this. Okay, because it's weird, but okay, you can see that it went up from 50 though, right? And it's like, I'm going to tell you guys what it is. Like 69, between 68, 69. Let's just say 69 milliliters. Okay, so it was 50 and it went up to 69. Okay, I'm writing this down so I can write your assignment later. So 69 milliliters. Okay, so now if you take 69 and you subtract 50, you will know the volume of these little guys. Okay? Okay, so this is one way that we're going to measure density is by weighing them and getting the volume of them, and then just figuring out, mass divided by volume equals density. Okay? But we're going to do it a different way too. Oh, did I turn it off? I hope so. Okay, and then it's going to be, we're going to do this another way. Well, you know what? I'll start. Okay, so first, you're going to take this and you're going to put it in this flask. It's called an Erlenmeyer flask, if you care. Okay, so I'm going to just dump all this in here. Water and the little plastic jewels and all. But that is not enough water to tell if they're floating. So I'm going to put another, conveniently, put another 50 milliliters of water in another graduated cylinder. So I'm going to dump that in there. Try not to spill it on my keyboard because that would be bad. Okay. Now, in some of these are floating, but not really floating because they just kind of get caught at the surface. I'm going to dunk them. So if I bump them down and they stay down, there they go. Okay. So not floating. They have sunk in regular water. Okay. So remember when we talked about density, oh, that's prettier there. Okay. When we talked about density, we said the thing that is more dense goes to the bottom, right? More dense goes to the bottom. Okay. And so they're the joules are going to stay their same density, right? Because we're not doing anything funny to them. So what we can do to make these float, to make them float, is we can change the density of the water. Well, how are we going to do that? Well, do you remember when we floated the 2 pop cans in the water the other day, and we had sugar pop and then we had diet pop? And the idea was that the water with the pop that had the sugar in it was more dense because it had more stuff dissolved in it. Okay, that is what we're going to do. Okay, we're going to put salt in this, and we're going to see as the water gets saltier and saltier, when do they float? Okay, all right, so let's start. So first thing that you write, and you're going to take data on this, you've got a data table of some sort. I got to figure out how to do this. I don't know. I always did this on paper before, but I'll figure it out. Okay, so first thing is you're going to say like, okay, in regular water's density is 1, because what we set it as, okay? Because everything kind of circles around water, because we love water on Earth. It's all the source of all life. Okay, so plain water does not float. Now I'm going to add a 1/4 teaspoon of salt at a time. Here's a 1/4 teaspoon of salt at a time, because I figured it out before. A 1/4 teaspoon is about 1.5 grams of salt. Okay, where's my salt? Here it is. You know what? I think this is going to spill if I do this way. So I'm going to pour out some salt into a little container where I can, there's a container. I'm going to pour some salt into it so that I can get it out 1/4 teaspoon at a time. Ooh, and that's probably way too much, but okay, whatever. Okay, so and I'm going to keep track of how many times I do this. Okay, so I'm adding 1/4 teaspoon, and then we're going to see what effect that has. Okay, so 1/4 teaspoon, measured it out. You know what, I'm going to tip this down a little. Tippy. Okay, so I'm going to take this, I'm going to put it into here, and then I'm going to dissolve the salt. This is why flasks are great, because you can do this. You can stir by just swirling around. That's very nice. That kind of makes a nice sound. All right, let's see, is that dissolved? And I'm looking in the bottom to see if I can see any salt crystals left, and a little bit, so. Swirly, 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 swirly. Okay, that's all dissolved. Okay, so now let's see what happened. Did that change it? No, see, they're still not floating. Okay, so not floating after 1/4 teaspoon. So I'm going to put some more. Another 1/4 teaspoon. And swirly, swirly, swirly we go. A little bit more. Okay, so all that salt has dissolved. And oh, I think I've got a couple stuck at the top, but I don't think they're really. We'll see most of the stuff is sunk still. Oh, we're gonna put this up a little so you can see. But I think those two, sometimes you just get them stuck on an air bubble. So if I poke them and they stay down, that just means they got kind of stuck at the surface. Yeah, they did. Okay. So still not floating. And that was 2 quarter teaspoons. So you're adding, so we added 1.5 grams, and then we added another 1.5 grams, and now we're going to add a third 1.5 grams. And we're just going to do this down there until they float. Okay, because that'll be another way of estimating what their density is. Because if they float, that means that the salt water is more dense than they are now. And we know how dense salt water is because we're measuring how much salt we put in. So it's just 2 different ways of measuring density. Let's see. Is there any more salt? Yes, it dissolved. Okay, I don't see any more crystals. Oh, no. Well, it's still those little ones. The big ones, if I can poke them and you can see some are, but if I can poke them and they stay down, then it doesn't. Because if they're, yeah, they just get caught sometimes at the surface. Because they would stay up no matter what. I could poke them down and they just pop up like a balloon. Okay, so that was the 3rd one. I think so. Okay, I'm going to put another one. I'm marking this on a paper. And stir, 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 stir. Actually, I haven't done this before. When I did it with you guys in real life before, last year, I had people stirring in a beaker with like a little stir stick. And this is actually more fun. And now that I have more plastic ones of these, next time we'll do this because this is more fun and it works better. Well, who knows? A lot of things in Corona time, we're figuring out stuff because it made us do stuff in a different way. Oh, now wait. Well, I don't know. Now I got to poke them and see because see some are floating, but they're not all floating, so I'm guessing not. Yeah, because if I poke them, they still go down and they don't come up again. Okay. All right, so I'm going to do another quarter teaspoon. That's another 1.5 grams. I'll mark down how many times. So now this is the 5th time I've been adding. All right, here we go. So crystal. Still a little bit. It's taking longer to dissolve, which makes me think that the water is getting more saturated with salt. A pretty little sound. Oh, now, okay. This is, now it really looks like it's floating now. Because look, some of them are, they're like going down for a second, but then they're bobbing back up. Okay, let me see if I can poke them in if they stay down. No, they're not staying down. Look when I poke them down. They come back up. Like if you look at the individual ones, yeah, they're coming back up. Sometimes slowly, so they're not super buoyant. Okay, so I'm going to say now the salt water is more dense than the little plastic crystals. So you can see they're floating now. So they were all sunk, but now we made it the water more dense by adding salt to it, and now they're all floating. Okay.